And it's great now to actually introduce you to a couple of speakers, a couple of presenters who are local. The Pivotal Lab is just 5 minutes walk away, where we do this day in, day out. We build and transform software. So I'm going to introduce Fede, who is one of our engineering managers from Pivotal Labs, and he's going to talk about something that I know that everybody has programmed and has in their code base of do not deploy on Fridays because we want to have weekends and we don't want to get disrupted. And Fede is going to talk a little bit about challenging the status quo. So welcome, Fede.
Hi, my name is Fede. I'm an engineering manager at Pivotal Labs. So today I'm going to talk about how to succeed, thrive, and learn from one of the activities that most organizations are super anxious about, which is going into production. We're going to see what are the common denominators across software development teams that make so much deployments to fail. And once we have identified them, we're going to see the strategies, practices, and patterns you can adopt so that going into prod becomes a mundane, recurrent activity that will help your business accelerate innovation. All right, so the no deploy Friday policy. Many organizations have decided not to ship software on particular days of the week, most commonly on Fridays. And this is because most deployments go wrong. So, but this constraint has a lot of downsides to the business. When suddenly your development teams tell you that they can make changes to the website so close to Black Friday, that obviously translates into a lost opportunity of revenue. And there are some reasons to avoid drama. We've all been there, right? So we want to mitigate post-release bugs only during business hours, minimize downtime impact, basically by choosing delivery time slots with less frequent activity, and do the business hour monitoring in the office and obviously not at home in the weekend, right? All right, so hold on. Not being able to deploy anytime seems like a symptom of a larger problem. And what are the side effects on the development teams where they are not confident to deploy at any given time? And how much is the business actually learning from the users with such long feedback loops? So let me tell you a quick story of Australian disruption. Canva is a startup located here in Sydney, and they are deploying multiple times per day. Basically, they've been able to tap into millions of users that found Adobe products very difficult to use, right? Now, they have democratized graphic design, and their customer base has grown exponentially. So what's going to happen with customers, with companies like Adobe in the near future? And if we take a step back, what are the actual reasons that makes teams take such decision? So let's see the common denominators. First, there's no repeatable processes in place to make sure that the deployments go right. And there's a constant presence of fear in the teams. They live in frustration because each time there's a release, there's so much at stake, right? And there's a shared mindset of what to do when it goes wrong instead of what to do so it goes right. So it seems like never release on Friday is another unwritten rule. Look at all these tweets from software engineers urging us, telling us not to release on Friday. Basically, the software engineering profession has a massive problem, and we are not talking enough about it. Some claims, such as never deploy on Friday, started as merely anecdotal, but they have become firmly established facts. And they are not backed up by any research whatsoever. So it seems like we found another leprechaun. I came up with this book from Laurent Vosevit, Leprechauns of Software Engineering, and he explains very well this phenomenon about unwritten rules in the software industry. He compares these facts as a variant of the broken telephone game. In this game, you have a group of individuals that whisper one message from one another. The last person then states out loud what was the message that was heard. And it's incredible to see how distorted that message becomes at the end. Like, for instance, adding more people to a project will speed production up. Well, this is certainly not the case in many instances. Sometimes when you onboard new software engineers, especially on technically complex projects, that adds a lot of overhead. Or how about every group has a programmer that is 10 times more productive than everyone else? We've all heard about the 10x kind of rule. I've been almost 20 years in this industry. I've never seen someone that outperforms by a factor of 10 their peers. And now we have never ever deployed software on a Friday, except that this rule has so much catastrophic connotations in it that to me it looks more like a rule from the Gremlins movie. Anyone that grew up in the 80s knows what I'm talking about, which is no matter how he begs, no matter how he cries, never ever feed him after midnight. So why is this practice widely followed? There are two components. The first one is that there are organizational bottlenecks. And here, this impairs a lot the teams. There are change approval boards, we all know them, that meet once a week, and they have to clear a backlog of petitions to go to prod, so you can have the go-ahead. You have manual QA with very long feedback loops. Also, what happens is that these QA teams, they don't belong to the product team. Sometimes they are in different departments or even offshore, and that delays the whole process of getting into production. And then there's a lot of red tape and plenty of sign-off processes all around. There's also a lack of continuous delivery practices. The deployments are highly manual. Well, there's too much at stake, right? The deployment script has become this massive beast that only a handful of individuals know to perform the different steps because everyone else is freaked out. They just don't want to perform it on their own, basically. So that creates a lot of silos. Also, the code is untested or has very low code coverage. And what happens with untested code is that no one really knows if the deployment is going to work, right? It's all about crossing your fingers and see what happens, hoping for the best. And failing or learning is not part of the organization culture. No one dares to break the status quo and basically change things around because it has become this massive beast with a lot of moving parts. This has several impacts on the business. The first one is that there's this increased fear going on. There's a hesitation to go after new opportunities because IT basically can't deliver often. There's also these long feedback loops that are drastically increased with the user, whereas competitors or newly disruptors, they are keeping gaining ground. How much are they learning from users that we are not learning? And obviously, that translates into market share loss. Not testing out ideas, well, it translates into a loss of market share, losing out opportunities, and, well, maybe even go out of business. That also has impacts on the teams. There's a reduced confidence. Suddenly, teams are not learning because they don't dare to touch those deployment scripts, right? And that translates into lots of stressful working conditions. First of all, teams, they are not delivering. They feel embarrassed because the business is basically saying that they can't deliver for the users. And also, being paged so many times during the month, it creates a lot of stress, and in turn, it creates individuals that are unhappy and disengages them. All right, so enough of bad news. Why don't we innovate and we deploy anytime, right? So enter continuous delivery. We've already heard a little bit about continuous delivery from the previous talks, about pipelines, etc. So what it is? Continuous delivery is the practice of building, testing, and releasing software into production environments on demand and fully automated. So basically what happens is that when the business asks the development team to deploy a particular version of the software, they kick off, they actually push a button, and they kick off the deployment pipeline. First of all, it's going to check out the code from a version control repository, such as GitHub. Then it's going to compile the code, produce ones and zeros, check the style, etc. And it's going to create the necessary artifacts that need to be deployed into production environments. After that, we're going to go through a battery of tests that are going to check whether there has been new bugs injected in that release and that the software is fit for production. And then it's going to deploy on any network, on any cloud, private or public. But for that, we need to do some work, and there are some prerequisites that need to be done before embarking on such journey. And the first prerequisite basically is to have continuous integration in place. And not to be confused with CD, continuous integration is a software development practice where developers integrate their code several times a day into a distributed repository such as GitHub. Each check-in is then verified by an automated build, allowing teams to detect problems early. And by integrating regularly, you can detect errors quickly and locate them more easily. Also, you have to basically keeping the software deployable must be a high priority for the entire product team. What does it mean? It means that you have to add features to the software in an iterative way. And to do that, you can choose from these two strategies. The first one is to use vertical sliced stories. This means that you are going to put stories, user stories, in the backlog that are very simple, and they are individual enough so that provide value to the user if the business decided to ship the software at that particular time when the story was finished. They must cover each architectural layer from the application, from the UI to the database, because otherwise you are doing horizontal slicing where stories focus on certain layers of the stack, like the database. But the thing is that when you finish these sort of stories, you can't put them into production because they need stories that are related to it, that belong to an epic, to be able to be shipped. The other one is to use feature flags. These techniques allows hiding features during runtime, and this is very handful. During development, a developer can enable the feature for testing and then disable it in production. And once the new functionality is ready, you can remove the feature flag, and every user can basically enjoy that new feature that has been shipped. We also need to have confidence of the code, and this is basically a must. In order to deploy on any environment, anytime, we don't have to cross our fingers anymore. We have to know that the code that we are deploying is actually working, right? And testing is the only way that is going to get us there, and in a quick way. Basically, testing is going to allow us to prevent bugs, and in turn, as a side effect, it's going to be able to let us scale up the code base forever. Because suddenly, when you have a battery of tests that fail, if you have injected a bug, you are more confident to clean up the code, to improve it, to add new libraries, to refactor it, etc. Even do drastic changes in the architecture. We also need to have this collective ownership of the code in place. And what it is, it means that the entire team is responsible for the code. Let's eliminate silos. This abandons the notion of individuals that own specific areas of the code. We also been in projects where there's the database person and the UI person, the release person. This code base is now owned by the entire team, and anyone can make changes anywhere. This eliminates the risk of having individuals that are the single point of failure. We also need to remove barriers in able to release autonomously. So let's reduce organizational red tape wherever we can so that development teams can deploy whenever it makes sense for the business. And ultimately, you want product teams to manage their own deployment pipeline. We also need a learning culture in place. So we must be ready to change the way we work and start learning practices such as how to manage an agile backlog, automation and DevOps, and software engineering practices such as test-driven development and pair programming. They are great to adopt continuous delivery. All right, now that we've seen the prerequisites, why don't we explore what are the strategies you can adopt today so that you can be able to iterate quickly. The first one is to convert your deployment checklists into code that automates the deployment. And what does it mean, this one? It means that you have to create the deployment pipeline. If you have a continuous integration pipeline, you can build the deployment pipeline on top of it. Make sure that all the deployment checklists scattered around Confluence are captured into automated scripts that run on the CD server. So basically create code instead of checklists. And then identify those people. There's always those people in organizations that are the only ones who know how to perform specific deployment tasks. Make sure they spread their knowledge around, and more importantly, that their knowledge is captured into code so that it can be now a repeatable action. Another great technique is to add information radiators to start building a CD mindset and maintain the momentum. These two images are information radiators from the Cloud Foundry team in San Francisco. So what are they? They are basically large displays of team information that is critical, such as the deployment pipeline, and that they are constantly updated. They are located in a spot where the team can see it all the time. And having the radiators visible will help the team nurturing accountability and amplifying feedback. Because whenever you're going to go back from your coffee pause and you see a red box, you're going to take action immediately. And if you start a new project, well, I encourage you to do it as early as possible. Let's not forget about adding automated tests that run on the deployment pipeline. Sometimes we have development teams that they have tests that run on their machine. But then when you need to put them, when you need to run them on the cloud, they tell you, well, it only works on my machine. So make sure that every test that is created can run in the pipeline so that testing everything can be a first-class step in this deployment pipeline. And this is a segue from Jerome's talk, but security is very important. We don't have to leave it aside. So be sure that you perform the necessary security steps as part of the pipeline. What does it mean? This means that things like static application security testing, now you can run it as part of the pipeline. This detects known vulnerabilities, such as SQL injection. And like this, you can avoid long feedback loops, getting these SAST reports many days after submission, right? And perform this task that each time that the code is checked in. Basically, let it scan your code base constantly. Don't let this at the end of the project. Also, you have to empower the team to self-serve. What does it mean, self-serve? So if your tool chain has become too complex, disconnected, and very difficult to manage and maintain, you have to empower product teams and give them a self-serving infrastructure with minimal guidelines. So that, because manual provision infrastructure, such as databases or message queues, takes time and is error-prone. So you want to eliminate high communication and operational and overhead cost. So basically, having a platform that allows you to self-serve, you can run any app on every cloud. Let the developers choose the programming language that is better for the job. I've seen so much organizations that can only run Java workloads or .NET workloads. That creates constraints on the team. And basically, it can also run on every cloud and allow the provisioning of services from the push of a button, instead of these long communication emails between teams to provision a Postgres database. The last strategy I encourage you to follow is to see the whole picture. So take a look around and ask yourself how the processes led by other teams are affecting us when releasing our workloads. Is the big picture streamlined? Your team can be as efficient as it can, but if the others are a bottleneck for you, you are no longer the efficient you thought you were. Let's take, for instance, onboarding an application into production. We've all been there, right? It's supposed to be a very simple 5-step process, but as soon as developers start to drill down on each particular box, they see Confluence pages that no one understands how they work. They are outdated. We always see last modified a year ago. How much has happened in a year in the organization? Is it still the case? Are these instructions legit? But besides process complexity, what happens is that each of these particular boxes is an island on its own. So basically, you have to hop on and hop off from island to island. And what happens is that there's waiting time between it. So how long does it take to onboard a new app into production? I encourage to go back to your development teams and you ask this question. And you will be surprised by the answers you're going to get. So don't end up like Asterix in the 12 tasks. Ever since I was a kid, I was a vivid reader of Asterix. In the 12th task, Julius Caesar, puzzled by Asterix's supernatural strength, he challenges him to complete 12 impossible tasks to confirm whether he is a god or an impostor. In one of the tasks, Asterix must get a permit from the most bureaucratic most bureaucratic empire in the Roman, for the most bureaucratic building in the Roman Empire. What happens in this building is that each unhelpful employee redirects their customer to similarly unhelpful employees, making the task of obtaining that permit impossible. Obviously, this is a parody of bureaucracy, but make no mistake, the development teams, they are facing the same hurdles as Asterix in this series. So if you want to learn about continuous delivery but actually making it, well, come talk to me or one of my colleagues. At Pivotal Labs, we pair with customers and we build software with deployment pipelines from day one. In here, you can see a government agency deploying into prod just a few weeks after incepting. Today, they have transformed the way they build software, and they are doing an amazing job. I look forward working with you. Thank you.